Good afternoon, guys. First of all, I wanted to start with this sentence because to me, maths is strictly connected with the concept of beauty. Think of how solid and harmonic this word is. Even its protagonists like pi, square root of 2, square root of 3 look like they have such an unreachable, deep and thin soul. And today you'll be delighted to discover the artistic side of these constants, how charming they are, because I've wrote in Matlab a code that reproduces a note and paints a color based on the digit of these constants. So let's head to the editor here to show the function. It's pretty complex at the first glance. So right off the bat we will start with the melody and then I'm going to explain as usual. Here I have a white circle and a pop-up menu with the constants pi, e, square root of 2, square root of 3 and golden ratio, which is basically 1 plus square root of 5 all divided by 2. Here I can choose which constant to play. Let's start from pi, for example, the great pi. And when I press the start button, the circle will begin to glow with different colors and will begin to reproduce notes, so it will compose a melody. Let's try this out. Cool, isn't it? That lasted about 30 seconds. Let's try with square root of 2, for example. Very nice. Let's see how I realize this function. Here, as you can see, as usual, you have some instructions that provide you to create a proper figure and proper buttons like stop, start and close. But besides that, we have a new type of button called pop-up menu with this string, which grants me to choose the constant as we saw before. Nothing new until now. Here I create some vectors associated with the color, because in Matlab you can use just blue, yellow, red, white and black, if I recall well, which are defined by which are default basically. But here I have to create some proper colors just by trial and error. Here's the circle, defined as a rectangle with a proper curvature and the color white. I know it's pretty weird that a circle is created starting from a rectangle, but this is how it works. Here I have the sample frequency and the duration of each note. Each note lasts about a half of a second, as you can see here. Here is the number of digits I want to scan. Of course, Matlab is not that precise. I mean, some numbers may be incorrect, but that's part of the game. And the duration of the whole melody is made by the digi times tempo here. So 75 times 0.4 is equal to 30 seconds. Here I call the start function, and as soon as the start function begins, the start tone button is set to 1 and it will begin to generate my melody. Here I have to know which constant you chose before, so it will evaluate the string that currently is present on the window. For example, I chose E, then we are in case 2, and the number pi ch, I called it like that, it's just a variable, it doesn't really matter, is equal to exp of 1 idest E divided by 10. This allows me to skip the dot, the decimal point. Here's the cycle. For every position in my string, because this time numbers are seen as strings for Matlab, for each position in my string I will begin to act differently. In case the number is 0, it will create a C note. Here's the frequency, and we'll set the circle white. In case we're dealing with a 1 digit, it will create a C sharp here and set the circle in red. 2 is a D and the circle is yellow, and so on with all the combinations. I just decided to associate that number with the colors. It's just my choice, you can do whatever you want, but the frequency is pretty important. I just looked up on internet which frequency are these notes, and I create a sinus with that frequency and use the command sound. This is pretty intuitive, and I did this job with every digit, with every number. But there are 2 notes left, because like in the piano you have 12 notes, and here the other 2 ones. If there is a couple of number in my sequence, then it will play A sharp if the couple is less than 5, and B note else. Here's the pause, which gives the correct rhythm, and if I ended the sequence, if I am at the end of the number, it we call the stop function. The stop function is defined as that, with the start tone that toggles, and it will pause a little bit to stop everything, and then the stop button will change with the start vector. Here's the close function. So it's not that complicated after all. For example, let's try to use a random pause. You will see a randomly generated melody with the random tempo. Let's try with E. You see? They are not regular. It's so weird, but you can define it as you want. You can use just a regular pause here, or you can make the notes quicker by reducing this number here, as you can see in this particular example. The notes are just quicker. Thank you so much, guy. I will post everything in the description. If you have some questions, just ask in the comments. See you next video.